Namaste students, welcome again. In our previous video, we have studied about all the properties of dioxygen. Now, in this video, we will talk all about the oxides. So, without any delay, let's begin. So, first of all, what are oxides? Most of the elements in our periodic table, they combine with the oxygen to form binary compounds, and the binary compounds of the metal and non-metal with the oxygen are known as oxides. So what is the definition of oxide? Binary compounds of metals and non-metals with oxygen are known as oxides. So most of the elements in our periodic table, they combine with the oxygen to form binary compounds, and these binary compounds are known as oxides. In most of the compounds, the oxidation state of the oxygen is -2. In majority of the compounds, the oxidation state of oxygen is -2. The oxides may be simple oxides or mixed oxides. So we will study simple oxide and mixed oxide one by one. First, we will take simple oxides. Now, we have number of simple oxides. It means simple oxides are classified into 4 different categories. We have number of simple oxides, and those simple oxides are classified into 4 different categories. The first category of simple oxide is basic oxides. Now, what do you mean by basic oxide? An oxide is said to be basic oxide. An oxide is said to be basic if it forms base when react with water. So whenever an oxide reacts with water, and after reacting with water, if that particular oxide form any base, then the oxide is said to be basic oxide. Now, oxides of alkali metals, alkaline earth metals except beryllium. So the oxides of alkali metals, alkaline earth metals except beryllium, and transition metals, they generally form the basic oxides. So oxides of alkali metals, alkaline earth metal except beryllium, and transition metals, they generally form basic oxides. So let us take an example. Suppose I have Na2O. Now Na2O is an oxide of alkali metal. So when this Na2O reacts with water, it forms NaOH. When this Na2O reacts with water, it forms NaOH. Similarly, if I take MgO, which is an oxide of alkaline earth metal. So MgO, when reacts with water, it forms MgOH whole twice. And if I take Fe2O3, Fe2O3 is the oxide of the transition metal. When it reacts with water, then it forms FeOH whole thrice. So in this way, the oxide of alkali metal, alkaline earth metal, and transition metal, when reacts with water, they form base, and because of this, these oxides are known as basic oxide. When the basic oxides reacts with acid, they form salt and water. For example, if I take any of the oxide, like Na2O. If I take Na2O, when this Na2O reacts with HCl, then it forms NaCl plus H2O. Then it forms NaCl plus H2O. Why it forms NaCl plus H2O? Because it is basic in nature, and due to basic in nature, it acts as a base, and when base reacts with acid, then we get salt and water. So it is a kind of neutralization reaction, but in this neutralization reaction, a basic oxide is reacting with the acid. Not a base is reacting with the acid, a basic oxide is reacting with the acid. Similarly, if Fe2O3 reacts with HCl, then we get FeCl3 plus H2O, like this. So this is basic oxides. So basic oxides, an oxide is said to be basic if it forms base when react with water. Alkali metals, alkaline earth metals except beryllium and transition metals, they generally form basic oxide. When basic oxide reacts with acid, they form salt and water. Now the simple oxide, the first category of simple oxide is basic oxide. Now this second category of simple oxide is acidic oxide. So second we'll study the acidic oxide. Second, acidic oxide. Now the definition is similar to that of the basic oxide. In basic oxide we have studied that an oxide is said to be basic if it forms base when react with water, and oxide is said to be acidic. An oxide is said to be acidic if it forms acid when react with water. So those oxides which forms acids when react with water, those oxides are known as acidic oxides. Now all non-metal oxides are acidic in nature. All non-metal oxides are acidic in nature. For example, CO2 plus H2O, it gives H2CO3. P4O10 plus H2O, it gives H3PO4. SO2 plus H2O, it gives H2SO3. So these are the oxides of non-metals, and when these oxides reacts with water, they form acid, and therefore these oxides are known as acidic oxides. And when acidic oxides reacts with base, when these acidic oxides reacts with base, they form salt and water. When these acidic oxide reacts with base, they form salt and water. For example, CO2 when reacts with NaOH, then it forms Na2CO3 plus H2O. So in this way, when these oxide reacts with the base, then they form a salt and an acid. So that's why these oxides are known as acidic oxide. Now here I have written that all non-metal oxides are acidic in nature. But beside non-metal oxides, some of the metal oxides in their higher oxidation state, they also behave as acidic oxides. In basic oxide, we have studied that transition metals generally form basic oxides, but if transition metals are present in the higher oxidation state, then they behave as an acidic oxide. So what is next? That metal oxides with higher oxidation state. Metal oxides with higher oxidation state, they also behave as the acidic oxide. For example, if I take CrO3, that is chromic oxide, it is the oxide of transition metal. So according to our previous concept, it should be basic in nature, but it is acidic in nature because in this the oxidation number is +6. So when this CrO3 reacts with water, it forms chromic acid, that is H2CrO4. So because of the formation of the chromic acid, this is acidic in nature. So some metal oxides in which the metal is present in a higher oxidation state, they behave as an acidic oxide. Now we move to our third category, that is amphoteric oxide. Third category is amphoteric oxide. Amphoteric oxides. Now, what are amphoteric oxides? The oxides which reacts with both acid and base, they are known as amphoteric oxide. Now, these oxides are formed by the elements which are on the border of the metals and the non-metals, like aluminium and lead and zinc and tin, etc. So these are the elements which are on the border of the metals and the non-metals, and when these oxides react, they react with both acid as well as the base. Therefore, these are termed as amphoteric oxide. Let us take an example. Oxide of aluminium, that is Al2O3. Now, when this Al2O3 reacts with HCl, when this Al2O3 reacts with the aqueous solution of acid, then it forms AlH2O whole 6, 3 positive plus Cl negative. So it reacts with the acidic solution, and similarly, if I take NaOH, then it forms AlOH whole 6, 3 negative plus Na positive. So it reacts with both acidic solution as well as the basic solution, and that's why these oxides are known as amphoteric oxides, because they react with both acidic as well as the basic solution. The other examples of amphoteric oxides are TbO, ZnO, SnO, SnO2, etc. So these are the examples of the oxides of the other amphoteric oxide. So amphoteric oxides are the oxides which react with both acid as well as the base, and these oxides are formed by the elements which are on the border between the metals and the non-metals. The example, two reactions are here, and these are the other examples. Now the simple oxide, fourth category. The fourth category is neutral oxides. Now neutral oxides are the oxides which neither reacts with the water nor with the acid or base. So these are the oxides which neither reacts with water nor with acid oblique base, and these are known as neutral oxide. For example, H2O, NO, etc. So these are the examples of the neutral oxide. So these are four categories of the simple oxide. Mixed oxides. So what are mixed oxides? Metal oxides which consist of two simple metal oxides with the metal in different oxidation state, they are known as metal oxides. So if we have to define the mixed oxide in a simple manner, we'll say that mixed oxide is actually a combination of two simple metal oxide. Means if a metal form two different oxide, then the combination of those two simple oxide, it becomes a metal oxide. For example, Fe3O4. For example, Fe3O4. Now, Fe3O4 is actually a mixed oxide which is a combination of Fe2O3 and FeO. We all know that from our junior classes, we know that iron is present in two oxidation state, that is +2 and +3. So therefore it formed two different oxide, Fe2O3 in which the oxidation state is +3 and FeO in which the oxidation state is +2. So when these two are present together, then we get Fe3O4. So Fe3O4 is actually a mixed oxide. Similarly, Pb2O3. Now this Pb2O3 is also a combination of two different oxides of lead, and these two oxides are PbO2 and PbO, and the formula is PbO2.2PbO. So what are mixed oxides? Metal oxides which consist of two simple metal oxides with the metal in different oxidation state. So basically when the metals are present in different oxidation state, they form different oxides, and when they combine, when they present it all together, when they present together, then we get the mixed oxides. And the property of mixed oxide is the property of both the oxide. It means if we have Fe3O4, Fe3O4 shows the property of both Fe2O3 as well as FeO. Similarly, Pb2O3 shows the property of PbO2 as well as PbO. So this is all about the mixed oxide. Now, if we talk about the acid-base character of oxides in periodic table, acid-base characters of oxides in periodic table. So as we move left to right in our period, if we move from left to right, for example, if I take third period, that is sodium. So first is sodium oxide, second one is magnesium oxide, third one is aluminium oxide, that is Al2O3. Fourth one is silicon oxide, that is SiO2. Next one is phosphorus oxide, that is P4O10. Next one is sulfur oxide, that is sulfur oxide becomes SO2. And next one is chlorine oxide, that is Cl2O7. So if we talk the acidic and basic nature of these two oxides, Na2O is highly basic in nature, strongly basic in nature, whereas Cl2O7 is strongly acidic in nature, which we have studied in this simple oxide. So as we move left to right in our period, what happened? The basic character get converted into the acidic character through the amphoteric character, because we get here amphoteric oxides also. So the basic oxide first get converted into amphoteric oxide, and then amphoteric oxide get converted into acidic oxide. So as we move left to right in our period, what happened? Basic character converted into the acidic character through the amphoteric nature. Now, if we talk about the S-block elements, in S-block elements, as we move down the group, for example, if I take Li2O, Na2O and K2O. So as we move down the group, what happened? Basic character increases. Basic character increases. It means K2O is more basic than Na2O, and Na2O is more basic than Li2O. We are talking about S-block elements, means alkali metals and alkaline earth metals. Now, if we take P-block elements, then what happened? On moving down the group, because in P block we have majority non-metals, and non-metals forms acidic oxide. So in P block, on moving down the group, acidic character decreases and basic character increases. Acidic character decreases, and basic character increases. So If we talk about a general period on moving left to right, the basic character get converted into acidic. If we talk about S block element on moving down the group, basic character increases. If we talk about P block elements on moving down the group, what happens? Acidic character decreases and basic character increases. Now suppose if we have different oxide of a non-metal, if we have a different oxides of a non-metal, then with increase in the oxidation number, acidic character increases. With increase in the oxidation number, acidic character increases. Let us take the oxides of nitrogen. The oxides of nitrogen. N2O, NO, N2O3, N2O4 and N2O5. In P block, in nitrogen family, I have explained this topic very briefly. So, suppose we have oxides of nitrogen. Now, out of these 5 oxides, in this oxide, nitrogen contains the maximum oxidation state. So, the most acidic oxide of nitrogen is this. This one is the most acidic oxide of nitrogen. Now, why this is the most acidic oxide of nitrogen? Because in this case, the oxidation state of nitrogen is maximum among the other 5 oxides of nitrogen. Similar thing we will observe in D block elements. Similar thing we will observe in D block elements. Now suppose if I have to compare MnO2 and Mn2O7, that out of MnO2 and Mn2O7, which one is more acidic? So I'll calculate the oxidation state of manganese. In this, the oxidation state of manganese is +4 and in this it is +7. So +7 is greater than that of the +4. That's why Mn2O7 is more acidic as compared to MnO. So in this way, we'll arrange the different oxides in the basis of the acidic and basic behavior. So students, that's all for today. I'll see you in my next video with new topic.